this a little bit more.
So I'm not completely sure what's the question of interacting with Near and Aurora from Ethereum, but certainly we have right now a product built in Aurora, which is called the Rainbow Bridge, which will allow to interact between Near ecosystem and Ethereum ecosystem. And in particular, with this sort of feature, we have put Near and Aurora ecosystem closer than they were before. So you will be able, as a user, you are able today to use Aurora using every Ethereum tool that exists. That's certainly true. And in particular, after we have this feature, you will be able to use, for example, MetaMask to interact with Near contracts. Not sure if this answers your question, or?
Yes, I mean, the end user will pay transactions with Ethereum.
Correct.
Is that correct? Yeah,
correct.
It still stands.
Yeah, so basically you will be able to pay Near transactions with Ethereum, right?
But with a fraction of cost.
Of course, like yes. the cost will be never more expensive than the whole Near gas. Right now, if I recall correctly, it should be about like 20% of the whole Near gas. So basically on Near you would pay 1 cent per transaction. On Aurora you're paying like 20% of that at the moment, and that will remain the case after this is created. It's still to be seen, the details, because there is no such application yet. Like this feature, it's already live on mainnet, and there have not been any applications so far leveraging this opportunity. And the relay, like Aurora, it's a completely decentralized, trustless project. The relayer we have in front of Aurora, which we consider a critical component in the success of Aurora, it's handled by Aurora Labs. So anyone can deploy their own relayer, like their own RPC interface. In particular, the one that it's subsidizing Aurora, it's our RPC. So details of how this will be managed in the future are still to be seen. But in general, the goal is to maintain it as it is today. So subsidizing as much as possible, so we make it as easy as possible for users to interact with the network.
Mm-hmm. And the native Aurora token, is it going to be governance token or utility?
Oh,
I didn't understand it quite.
Oh, that part is not completely related. So basically, suppose, I think, for example, there is this application, Origami, deployed on Aurora. Origami has their own token. I think it's called Origami. And they deploy their token in Aurora initially, right? So they want to put their token on DEXs on Ethereum. What this feature will enable is that they will be able to move their token to Near, as it works with other bridges. And then from Near, they will be able to move their token to Ethereum. So that's the whole point of native RC20 tokens from Aurora to Near. Your question about Aurora token in itself, there are plans, like active plans that you can follow both in Aurora forum and GitHub about how Aurora token will be used for the governance of the Aurora project. Currently, there are some details of the ongoing research and efforts on Aurora Plus page. Both, I recommend Aurora Plus. There you will learn a little bit about this token called Votes. And in Aurora.dev, there are some details as well about how the whole governance will be working. But there are still a lot of details to be agreed on.
Of course.
Yeah.
Thank you. Thank you.
Welcome.
So can you explain those Aurora addresses on Near? Like, is it exclusive only for the contracts on Aurora, or?
Can you repeat the first part?
Aurora addresses on the Near. Like, is it exclusive only the contracts that are living on Aurora? Or?
Yeah, basically like 0x.beef in this case, 0xbeef.aurora, this contract, it will have a special function that will be called, I don't know, execute. That's how it's called today. But this function execute will be guarded in a sense that it could be only be executed by the Aurora contract. If someone else tries to call this function, it will just fail with not enough permission, something like that. So that's how we make sure that this contract cannot be abused. and they are actually representative of the Aurora address on near blockchain. Yeah. Okay, thank you very much, everyone.
All right, our next and last presenter is Belma Gutlic. She's at ChainSafe. She actually started her own blockchain business called Node Factory a few years ago. They sold it to ChainSafe, and now she's here to talk to us about securing decentralized systems with MPC. So, give her a round of applause. Come on.
So I guess this is it. Thank you everyone for coming. I know what time it is, so you must really like cryptography and blockchains. So yeah, thank you for being here with me. So bear a little bit, and I hope you will learn something new and maybe find something interesting here. The reason why I chose this presentation is MPC, that stands for multi-party computation. Is actually a cool piece of tech that can be a solution to a few use cases that we'll go through as well. Okay, so first a little bit about me. My background is engineering. I guess I like to mention that now that I work mostly as a manager. Yes, I had my own company called Node Factory and exited it last year, and I'm now part of ChainSafe. That's building Web3 infrastructure, and I run a research department there. One of the things I'm proud about this year is co-founding NGO Alice in Blockchains. Also from other local community things, we have UBIC that I'm also part of, and we're mostly focused around regulations and education. So that's kind of briefly about me. When it comes to ChainSafe, as I said, we're building the Web3 infrastructure, and some of the things we're working on is protocol implementations and building client software and building that client diversity. And the nodes that we are developing is like Ethereum for Lodestar for Ethereum, Gossamer Go client for Polkadot, for Mina protocol, and for Filecoin as well. A bunch of other stuff that we're working on inside the whole ecosystem and different blockchains. And yeah, a lot of cool stuff on the research side as well that I'm proud about. And yeah, that's kind of mostly about it. So let's kind of start with maybe reminding some of the questions like maybe we had before that maybe MPC could help us with. So, like, maybe we have asked this at some point, but like, what if our private data is not held by someone else, by a centralized entity? Like, what if we can keep this private data to ourselves, still have the same computation, still have the same results, but we are not sharing that data? The data is kept only to ourselves and never shared with anyone. Also, for those familiar with crypto and key management, like you may also experience the troubles that private keys bring, and that is, writing down seed phrase on a piece of paper, or maybe using some custodial services and having your actual wallet on exchange, which is, not a great option, and neither of these are maybe great. So what if we can move this responsibility of signing and transaction management to maybe decentralized parts? Also, I'm sorry, the timer is wrong a little bit. If you can fix that, please. And also, maybe with the MPC, we can do some other privacy-preserved computation. And I want to just emphasize with this slide that MPC is not only crypto technology. It can actually have applications in other areas as well. So note that. So what is actually that MPC? Well, it's a cryptographic protocol that has started theoretical research in late 80s, and it has been theoretical for a while until it started kind of gaining more progress and turning to more application use. And nowadays we can use it in production. We have systems that are performant enough to use it, and applications do use it. Let's say it's ready to use. How it actually works is here we have our MPC, not black box, but yellow box. And what it does in this example, it just simple addition. So on the left side, we have private data. We have private data. So we have some encrypted X, encrypted Y, and on the right side, at the output of this MPC protocol of ours, we have not encrypted data, but public data, and that's the result of X plus Y. So what has been done here is basically computing on private data that's never revealed to anyone, to having a public result that you can trust. So MPC guarantees both privacy and the correctness of the result. That's kind of a main takeaway of all of this, like what MPC actually is. Private data on the inside, and output is public correct data. And it is a shared computation, of course. But let's dive into an example. Here we have a task to compute average salary among a group of friends. Since they're a group of friends, they don't want to reveal each other's salary. So let's see what we can do here. We have Alice here that has 100K salary. We have Bob here that has 110K salary. And we have Eve here that has 130K salary. Obviously not Solidity devs. And actually, this example is somewhat data analysis that was used a few years back in US to calculate salary gender gap. So MPC was actually used there in an application. So not so stupid example. But back to it, how it works. So we have salaries, and we want to get average. What we can do, they can each send their salaries to a trusted party that will calculate that result for them and just say, hey, this is the average salary for 3 of you guys. But no, we are smarter than that now. We don't need a trusted party to compute this. So we don't want to reveal any data, not any private data. That is salary in this case. So this example works by this function. Let's say Alice chooses a random number. In this example, that random number is 54K something, and she adds it to the salary and sends it to basically her peers. She broadcasts that message. But Bob receives now that message. And Bob, as a next step, as a next round, he only does compute his salary with the received number, just simple addition, and sends it next. So 110K plus Alice's received number, 154, gives us this 264K result. So Bob only does that. Also broadcast again to everyone in the network. Now it's Eve's round to participate in the protocol. Eve does the same thing as Bob does. She just adds the received number to her salary and sends it again. Now here is Alice. As the last part of this function of our protocol, Alice does subtract the random number that she initially created and divides the result by 3 to get the average result. So super simple math, and we have the average result as an output. What actually happened here, I mean, also it was broadcasted to everyone else. So what we actually have here, and what the protocol guarantees, again, as I said, only output was learned. So Alice only revealed the final number of the average result at the end, and that we can verify that actually that output is correctly computed. Like when working on implementation of MPC, like libraries will usually do this for you, depending what you're doing. So like you can trust the protocol, it will either output the result, but if someone is malicious, depending how you configure the protocol, it could fail. So it's either success or fail, let's say. And this would work even if some of the parties are dishonest. It's important that at least one party is honest. So let's say Bob and Eve are colluding, but Alice is honest. Like she would, be able to say, okay, this is not the correct result, and MPC protocol would fail. Of course, like in a decentralized system and in automated systems, Bob and Eve will probably say, hey, let's kick out Alice because she's lying, although Alice is honest, but she is not the honest majority. So it's important to still have that majority when it comes to functioning live network, live protocol. So that's basics of how MPC works. Let's see kind of now the area that can really apply to crypto and how we can handle keys and some decentralized systems today. So we have something that's called threshold signature scheme. And what it actually does is, helps ourselves in a key management that, not every participant in the network has its own key that then signs things, but rather all the participants in the system, like all n of them, have only a key share. And what they do is make only the partial signature. So each one of them will make a partial signature using the key share, and just then it will be assembled into one single signature. And in case of blockchain system, that's when you'll submit the signature on chain, maybe do some smart contracts logic there to verify that and execute the logic, but everything else is kept off chain. That's why they can, it can be similar and comparable to off-chain multisigs, but in case of this, obviously it costs less and also enhances a bit of privacy. What's interesting is what's this quorum based? Well, each round you can select only a subset of those n participants to participate. So not every time you need really all of them to be online and to do their part in the protocol. It's important to mention that shares are never assembled, so it's not like we assemble them in one place and then distribute. That never happens, and they are never revealed between each other. So, how we can design this perfectly, like how much threshold value should I use? And that's like an interesting problem because it really depends on the use case. So if you set the threshold value to be, really high, you will get that security, you will get robustness in case of, you're minimizing the risk, you have more participants, and therefore it's harder for them to collude. But you lose performance because you need so many messages between so many participants, so it's slower. In the other case, like if you lower the threshold, then obviously you have much more performant protocol, and a lot of peers, not all of them not so many need to be online as well. So you're getting more liveness out of protocol to work, but you are losing that security a little bit. So it really depends on the use case and what you're doing and how much fast this should be and so on. Yeah, let's jump to a few use cases and see where we can actually put this in use. And that's it in more secure wallets. So right now we have, as I said, seed phrases, the 12 words that we need to write on our papers or somewhere more robust. And that's not ideal for any kind of person. Let's be honest. Like even if you're a newbie or a professional, you still have that little bug in your head that's bugging you. So alternatives right now is like let's use custodial wallets. Like let's use those service providers that will just create us wallets. Why not? But we know that not your keys, not your crypto, and that's just not what we're looking for. But with MPC, it seems like that we have a perfect mix of security and user experience. As when it comes to user experience, it's no more mnemonic phrases, and we still have secure key management. This actually can be seen in services or wallets such as Zengo and TORUS. How Zengo works is actually very simple. It just keeps at least last time I've seen it, they improve a lot. But they just keep one share at their server, and they keep one share at user's device. But TORUS has a third share as well. So what TORUS does is basically creates 3 shares for user. So when user is onboarding, wants to create a wallet, if you use TORUS's SDK, wallet, whatever, they will do this for you. So what they do actually is create, one share based on your social login, like Gmail, Facebook, whatever they support, and they keep it authenticated using the social login. So that's kind of how one share is created and how it's encrypted and stored. We have a second share that's on user's device, specific to it. And we have a third user's backup share that all uses password, whatever user gives as an entropy. So in how it actually works, once these shares are created, that you usually need 2 out of 3 shares to sign a transaction. So in case you don't have one, or you can, if you lose one, you can always restart all that procedure and just do key reshare between everyone else. So if you lose one, you still have your wallet and you still can reset all of that. So there is some redundancy even there. And same goes if one is compromised, then you can still use the other two to start the reshare. Another similar situation or similar use case is in bridging. This is the example that I use because ChainSafe contributes to building a SYGMA bridge. And what we encountered in this concrete situation is, did we have problems with how the bridge previously worked? Sorry, for those who don't know what bridging is, it's basically moving assets from one chain to another chain. So in case of SYGMA, you would move maybe from Ethereum to Polygon or to some maybe substrate-based network or whatever. So moving assets between 2 chains. How it worked is having multiple relayers, and they all had to sign their transactions on chain, which was obviously slow, and it costed a lot, especially on Ethereum mainnet where gas prices were very, very high. So what we did here is replace that part with something that's more off-chain and something that will disable all these problems. It will remove the costs, but it will not sacrifice security, which is cool. So we still have the relayers that could be trusted and all this process that could be trusted, but just kind of gained in a different way. And yeah, we do use each round the thresholds to make sure that our bridge operates at the all time, but not that much at the cost of security. I think I'm kind of on the end here, so I'm happy to talk about MPC or any of the things that you've seen here. So yeah, you can find me later, or I think you can also contact me if you want. And we can take QA, I guess. We have a few more minutes, so yeah, happy to answer any questions that you guys might have. Thank you. Okay, we have one.
Hi, I have been exploring in the past with Near team about MPC for doing HTTPS handshake. Like main idea is that we want to bring Web 2 data to Web 3 ecosystem, but HTTPS, it's very easy to forge information, right? So have you played with that? Do you have any sort of insight if that could work?
I think I need more context. Sorry, like which part are you trying to plug in?
Sorry, fair enough. The communication, like when you establish like SSL communication with the other party, you both agree on some symmetric and cryptographic communication, right? So the whole point is to have an MPC system in the querying side, so no one can forge a new message.
Okay, yeah, that's an interesting one. I'm not sure like if MPC would be the best solution for that. I mean, like there are other existing, maybe handshake protocols or whatever that you can maybe make more advanced to achieve what you want. So yeah, like without looking kind of much further into it, I'm not 100% clear on the answer. But yeah, happy to discuss that. Yeah. Okay, we have one
there. Very nice talk, thank you. I wanted to ask which threshold scheme you actually use among those bridge relayers?
Yeah, I'm not sure if I can talk about that. Is that thing open source? Yeah. I don't know, is this recording? Yeah, maybe we can talk also that a little bit later.
Okay.
I'm not kind of 100% sure if we can talk the details because it will be released soon. It's
Understood.
Still, yeah, thank you.
But it is used in chain bridge, right?
Yeah, previously called chain bridge.
Okay.
I hope this is one I can answer.
You can try. Thank you for the talk. Lovely talk. Just a question about MPC and maybe a competitor. That's the question. The TEE environments, right? That are popping out and they are becoming a commodity. Yeah. And it's more easy to have a secure place to do some computation. So is MPC kind of getting into its own niche, or where is it going to be a go-to protocol? Because it might be that it's going to be replaced by other technologies, right? So that's the question.
Sorry, it might be that it will be replaced?
By, let's say, a TE trusted execution environments, which are kind of becoming more and more ubiquitous all around, right?
I mean, I would say it's a trade-off. I'm not sure that everyone likes really trusted executions environments. So.
Okay.
Yeah.
I guess that's an answer. Okay.
Yeah, with MPC, it's a little bit different, so you don't need that.
So do you see like MPC some kind of usage for not revealing personal data, but asserting some kind of personal data? Do you see some use case like asserting personal data because it's a different computation, but you don't reveal your secret, I don't know, your age, but you assert that you are not a minor or something like that?
I mean, yeah, like I'm pretty sure that any kind of private data would work, but it kind of depends if you want to use MPC or some other maybe ZK more based stuff. it can be all combined, but MPC, I guess, it's maybe used in larger data sets. As I mentioned, kind of the data analysis that that was used before for data analysis of the salaries and gender gap, and maybe healthcare and I don't know, voting systems, kind of use cases like that. It's not solution to all things. That's kind of what I'm saying. Okay, thanks for the questions, but happy to discuss those more in private. Thank you.